morning, children. Sairam. Children, as we have already finished the first chapter of your syllabus, so today I'm starting with the next chapter, that is structure of atom. The structure of atom. In this chapter, we'll be learning about the different models which were given by different scientists for the structure of atom, and after that we'll study about the particle of the nature of particle. Now let us begin with the chapter. See children, as you all know, atoms are the fundamental building blocks of matter. That means each and everything present in this universe is composed of atom. The smallest particle is atom. It was considered to be the smallest particle, but now it is not so. Now the word atom has been derived from the Greek word atomio, which means incuttable. That means previously it was supposed that atom cannot be further divided into small particle. It was supposed to be the smallest particle, and it was supposed to be indivisible into smaller particle. John Dalton, he gave his atomic theory in 1808 and he regarded that atom is the ultimate particle of matter. In 1808, John Dalton gave his atomic theory and said that atom is the smallest indivisible particle, or you can say atom is the ultimate particle of matter. This was told by John Dalton. Now, later on, in the end of the 19th century, experimental observations were made by different scientists, and they said that atom can be further divided into subatomic particles. So, in 19th century, it was proposed that atom can be further divided into small particles which are called the subatomic particles. That means the small particles which are present inside the atom. So, they are called the subatomic particles. The examples of subatomic particles are electrons, protons and neutrons. So, we have two subatomic particles here right now which we are going to study. These are the electrons and protons. Now, we'll study about the discovery of electron. Now, as such, it is not there in your syllabus. You all have already done this in 9th standard, but still will be revising a little bit. Actually, your syllabus for this chapter is starting from Bohrs atomic theory, Thomson model and Rutherford model of atom. In 9th standard also, you must be remembering you were having a chapter, structure of atom, in which you all have learned about the Thomson model of atom. That was like a plum pudding. That means there is a sea of positive charge in which the electrons are embedded. It is like a watermelon. That was Thomson model of atom. Later on, Thomson model was discarded by Rutherford, and Rutherford conducted an alpha scattering experiment and gave his atomic model, and the nucleus was also discovered. Now, the third model we'll be discussing here, that is your Bohrs atomic theory. He gave the structure of atom and explained about the distribution of subatomic particles inside the atom. Now, before that, we'll do a little bit about the discovery of electron. Now, see, Faraday conducted the cathode ray discharge tube experiment and gave the atom. In this cathode ray discharge tube experiment, what is there? We have a evacuated glass tube. We have an evacuated glass tube which has two electrodes, the positive and the negative electrode. A gas is filled inside this, a vacuum pump is there, and when electricity is passed through this, the rays came out, And the result of these experiments, I'll read it out for you. The cathode rays start from cathode and move towards the anode. The rays will come out when electricity is passed, high voltage is passed, and they come out from the cathode side and move towards the anode side. Now these rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials like fluorescent tubes, and which glow when they hit them, like your screen of the TV. Previously that fluorescent screen was used, nowadays LCD is there. And television picture tubes and cathode ray tubes television result due to the fluorescence. Yes, the appearance of the image on the television, it also appears because of the fluorescence on the television screen that is coated with certain fluorescent subject, or you can say material. Next is, in the absence of the electrical or magnetic field, these rays travel in straight line. That means these cathode rays can travel in straight line. Only the deviation takes place when there is some magnetic or electric field. In the absence of electric or magnetic field, the behavior of cathode rays are similar to that expected from negatively charged particle. This suggests that the cathode rays consist of negatively charged particles called electrons. This was the discovery of electrons. That means the cathode rays are behaving in the similar manner that a negatively charged particle can behave. So it was considered to be made up of electrons. Now, the characteristics of cathode rays do not depend upon the material of electrode. It depends upon the nature of the gas which is present in the evacuated glass tube. Thus, we can conclude that electrons are the basic constituents of all atoms. Now, what is the charge of an electron? It is taken out by the charge to mass ratio method, and the charge of electron comes out to be minus, electrons are negatively charged particles, so it comes out to be minus 1.6022 into 10 raised to the power minus 19 coulombs. Next is, we'll study about the discovery of protons. Now see, the electrical discharge which when it is carried out on the modified cathode ray glass tube led to the discovery of particles carrying the positive charge, and it is called the canal rays. The smallest and the lightest positive charge, it is obtained from hydrogen and is called a proton. Hydrogen, sometimes it is also written as H positive. Now see, the neutrons. The neutrons are the neutral particles which were discovered very late due to the absence of charge on this, and were discovered by Chadwick by bombarding a thin sheet of beryllium by alpha particles. And so, how the neutral particles were discovered? The neutral particles were discovered very late by Chadwick by bombarding a thin sheet of beryllium by alpha particles and were named as neutrons. So, the positively charged particles, they are called protons. The negatively charged particles are called electrons. And the neutral particles are called the neutrons. Now see, the properties of electrons, protons and neutrons, they are summarized here in the form of a chart. You all can see, electron is represented by symbol E, proton by symbol P and neutron by symbol N. Now the charge, the absolute charge which is there on electron and proton, they are same, that is 1.602 into 10 raised to the power minus 19 coulomb. The only difference is that the charge on the electron is negative and that on the proton is positive. Yes, and neutron will be 0. Now relative charge, we say that it is one negative and one positive. If we see the mass of electron and proton, then we can see the mass of an electron is 9.1 into 10 raised to power minus 31 kgs, and that of a proton is 1.67 into 10 raised to power minus 27 kgs. Now see, the mass of proton and neutron is almost similar. Now coming to the next important thing, from here exactly your chapter starts, that is the Bohrs model of atom. You have already learned about Thomson model, Rutherford model. Now we are studying about the Bohrs model of atom. Now let us first start with the characteristics of Bohrs model of atom. See, the first thing is the electron in an atom can move around the nucleus in a circular path or fixed radius and energy, and is called a orbit. What according to Bohrs is there, what Bohr explained is that electron can move around the atom in circular paths of fixed radius. That means this path has a fixed radius. That means the distance between this middle point and the path where the electron is moving is fixed, and the energy is also fixed. And these circles are concentrically arranged around one another. That means concentrically around outside the nucleus, and he named these paths as orbits. Remember, Bohr has called the path around the nucleus in which the electrons can move as orbit, and he said that it has fixed energy. Now the second point is, the energy of an electron in an orbit does not change with time. What is its meaning? Suppose this is the nucleus. This nucleus is filled with the positive charge. The electrons are present around the nucleus and are moving in this circular path. Now what Bohr has said, that the energy of the electron in a particular orbit is constant as long as it remains there. Now if suppose from some source it gets some energy, this is some source, it is getting energy from this source, so what it will do, it will jump to the higher orbital and will reside here for some time. That means as long as the electron is present in a particular orbit, the energy is always constant. But if it gets an energy from some outside source, it becomes excited and jumps to the higher orbit. Now one thing you have to remember, it cannot remain in the higher orbit for more time. It becomes unstable here, so it jumps back to its original orbit, and at that time of coming back, it will give out the same amount of energy which it has absorbed during the process of going to the upper orbit. Now next point is, the frequency of radiation absorbed or emitted when transition occurs between the orbit is given by nu. Frequency is denoted by nu is equals to delta E upon H. Now what is H? This I will be explaining you later on in the part of the chapter. In the same chapter I will explain you later on, because you will not understand if right now I will say. And what is this delta E? This delta E gives you the difference in energies of the higher orbit and the lower orbit. So the frequency of radiation absorbed or emitted when the transition occurs between the orbits, nu is given by delta E upon H, where delta E is the difference in energies of the two orbits where the transition is taking place. Next is, the angular momentum of an electron in a given stationary state can be expressed by nh upon 2 pi. So it can be given by angular momentum is there. MVR. This is not MOVE. It is MVR. This MVR is equals to NH upon 2 pi. This is the angular momentum of the electron in a given stationary state. Momentum, I believe you all must be knowing. What is momentum? Is mass into velocity. When it is going on in the circular path, then it becomes mass into velocity into the radius of that circular path. So children, for today this is enough. I'll tell you that about the Bohrs model in detail in my next presentation. Till then, kindly note down all the notes that I have given you here in the form of slides, and do try to read out the Bohrs model of atom from your NCERT book. Thank you. Sai Ram.